So now to begin with, I don't have this circuit working perfectly at the moment for the demonstration, but it's going to have a cool effect. So I just dimmed the lamp. You may not have been able to tell as much on camera other than the LED. Red LED probably looked a little bit brighter. Now I'm going to turn the lamp off, and this circuit is responding to light level. But let's see, yeah, it instantly goes to red right there, but it takes a little while to go to blue right there. So what I'm thinking is that this light dependent resistor, obviously its resistance changes based on light level, and when you have a drastic change in light, I'm guessing that its resistance for the most part changes extremely quickly, but when it's finally getting to its when it's getting closer to its final resistance, maybe there's just a little bit of delay. And I have this set probably right at that point, right, maybe at the perfect point where we get a fade to a low output there. So yeah, we'll zoom in to the schematic to take a closer look what's happening. Of course, you have to power the integrated circuit. I'm using an LM358. There's 2 op amps on there, and I'm using 1 out of 2 of them. I don't necessarily have to use 1. I could have used number 2 instead, although on this board, wiring it would be a lot crazier. So we're using number 1 right there, but we're using 1 out of 2 of them. And so that's one way you can tell when you're looking at a schematic if there's more than 1 op amp on that integrated circuit. There's another one, I can tell just from looking at the schematic, that I can make more circuitry with without having to add any more op amp integrated circuits, because we got 2 on this one. Hopefully that makes sense. So in any case, also, we have the plus up here on the schematic. Always be careful when you're looking at op amp or comparator schematics where the plus and the minus is, because they're always in the same spot on the physical circuit. So here it's actually lower, and the plus is lower than the minus, where on the schematic the plus is above the minus, and of course the physical component, it will never change. So no matter what the schematic does, plus is down there and minus is there. But you can see we got our light dependent resistor, and I'll darken it with my finger, and that's not dark enough. Okay, yeah, the lamp's even at the dimmest setting. That's interesting right there. So yeah, it flipped quicker now because I had my finger on it. So it gets darker when the light is off. So it's going to flip a lot faster. So now, the thing with this though is that, and hopefully, let's go back. It's wired as a comparator. There is no feedback either way. So, you know, stray signals and stuff can kind of like affect it and whatever. It doesn't lock into place. There's kind of a middle ground region, whereas we saw that like fade from one to the other. And so this is not the best way to make a switch. You'd want like a little bit like a high value resistor coming back. So when this does get higher than that one, then this pulls it up even more. And then when this voltage gets lower than this one, so that the output flips, then the output will keep pulling it down even more. So you got to overcome a middle ground region where it'll stay in either state, you know, Schmidt trigger. So I didn't add that here, but to make a good switch, you probably would. And of course, the blue LED lights up when the output goes low. The red LED lights up when the output goes high. We don't get the full 5 volts. We don't even get the full ground voltage. But it's even worse for the full 5 volts. Red LEDs don't get as bright at the same current. So I got a lower value resistor than the blue LED. Trim pot is an adjustable voltage divider. And so is, manually adjustable. And the light dependent resistor is a adjustable voltage divider, but based on how much light is falling on it. So we have a better connection the way we have it wired up. Better connection when there is a brighter light, so it raises the voltage at the non-inverting input. Current doesn't go in or out, just looks at the voltages of these two. That's important when you got something like this where the voltage would be thrown off if it had to provide current. And then when it gets darker, it's like it doesn't exist, and then we got a better connection down there. So we can adjust the sensitivity with that resistor right there, that fixed resistor. I'm using a 10K trim pot. Doesn't really matter what value you use. You could probably go too high at some point. But for the most part, this is just looking at the voltage. So the higher the better. But people seem to have like lots of 10K trim pots and potentiometers and stuff. So I think that's why you see them in so many schematics. And here we go. So the trim pot. All that's doing is adjusting the light sensitivity. So unfortunately, I can't make it where the lamp is at the dimmest setting right now. I can't make it where the output is low, no matter which way I go. And I haven't adjusted this a lot. I don't have a perfect feel for the right thing to do. Let's turn the lamp off, and there you can see it is still red. So what I'm going to do is turn this up to blue, and so I want to find the perfect spot where it changes, and this is actually how I got it to be where it will fade when I turn the lamp off. I was going too slow there. I should have realized I had to go down way a lot. So now I went down a little too far. Going to work my way up until the blue turns on. And there you can see like a middle ground region. Hysteresis would get rid of this middle ground region right there. But yeah, I'm going to go there and make sure that it goes full blue. And when I released it, it must have released the pressure that I had, and so it bounced back a little bit. There we go. So yeah, it's a little finicky on adjusting this, but I just keep turning this voltage up, the inverting input voltage, until I got the blue right there. Now I turn the lamp on, and then now we got the fade. But if I turn this more drastically right here, then it'll be quicker right there. So in any case, again, lots of ways to improve this. Generally, you don't want to, switch lights, based on light level or whatever. You would find something else. Either, probably switch a transistor, either with the positive or with the negative, depending on whether you're using NPN or PNP, to switch a higher power load that does something more interesting. Or you could control a relay or something. That gives like a weak signal. Again, you'd probably want to use a transistor, although this might work. And you use that signal to switch a relay, which moves a mechanical switch. So the electrical signal causes a magnetic field, which moves a switch. So whatever the load is being switched, none of the electricity from that load is involved with this circuit here, unless you were using the same power source. It could be a completely different power source altogether. Yeah. Not terribly complex, but I think an interesting circuit, especially because it's adjustable right there. So I hope you enjoyed. It was the last light dependent resistor circuit on this page that I printed out. All these recent videos were on this page. I think I covered every single circuit that was on this page. There's another one, at least one. Nope, there's one I didn't do. But in any case, you probably don't care about that. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.